Assalamualaikum and hello. In this video, we are going to focus about chemical properties of benzene. So let's focus with the type of reactions for benzene. What is the type of reaction for benzene? If you still remember, I taught you before, benzene has higher density of electron, so it will be nucleophile. When benzene undergoes chemical reaction, the reaction will not happen in the ring because due to the calculus structure of benzene. This is because the delocalization of pi electrons in the ring cannot be disrupted, or another meaning, it cannot be disturbed. So that's why the reaction will not happen in the ring, even though it got the double bond. Same with alkene. So in this case, what will happen when benzene undergo the chemical reaction? It will happen around the ring, where you can see around the ring you got hydrogen. So this hydrogen is what will be replaced with electrophile. So the type of reaction will be electrophilic because electrophile will be replaced in this reaction. And benzene is aromatic, we are going to put aromatic. And due to electrophile replace the hydrogen around the benzene, so it will be substitution. So this will be the type of reaction for benzene. And please remember, one class of compound can only undergo one type of reaction. So the only type of reaction for benzene will be electrophilic aromatic substitution. Now, we are going to focus one by one for the reaction of benzene. The first reaction will be halogenation. When I say about halogenation, of course, in this case, I'm going to use my benzene reacts with halogen. And for your information, in this reaction for benzene, it is very important for you to use the Lewis acid. We need to use Lewis acid because we need to activate the electrophile in this reaction. So the choice of Lewis acid can be FeX3 or AlX3. X can be SBr or ClorCl. So choose whichever you comfortable with. And right now I'm going to use my benzene plus reacts with my halogen, can be Cl2 or Br2. And please make sure when you choose your halogen as Cl, automatically your Lewis acid must be FeCl3 or AlCl3. It must be with the same halogen. You cannot use here Cl2 but here FeBr3. No, the reaction will not be happen there. So how this reaction proceeds? One hydrogen surrounding around the benzene ring will be replaced with one halogen atom from X2. So it will attach here, and this hydrogen will combine with another X atom. So you will have your product here. This one will be your major product, and this one will be your side product, or what we call as byproduct. Settle for halogenation. Let's go to the second reaction, which is alkylation, or the full name is Friedel-Crafts alkylation. This is from someone's name. And in this part, you got benzene reacts with RS. R here is your reagent, where can be alkyl group. So I hope you all remember, alkyl group can be any alkane with less one hydrogen atom. So it attach with halogen. Halogen can be Cl or Br, and of course you have to put the Lewis acid on the top of the arrow, and the reaction will proceed where you got hydrogen from the benzene will be replaced with the alkyl group from your reagent. So your alkyl group here will be replaced with alkyl group from this reagent. So R will be attached here, and this hydrogen will combine with your halogen. So this one will be your side product. And please take note that in this case, we are doing substitution. So H atom from the benzene will be replaced with another group. Please make sure as well, when you choose X here and X here, they are supposed to be the same one. Now let's go to the third reaction, which is nitration. For nitration, you got your benzene reacts with the reagent concentrated nitric acid HNO3 and concentrated sulfuric acid H2SO4. So you have to put plus concentrated nitric acid here, and your concentrated H2SO4 must be on the top of the arrow. And you have specific condition for this reaction where the temperature should be between 50 to 55 degrees Celsius, or more specifically 60 degrees Celsius. You cannot put the condition as triangle or heat. This one is not acceptable. No. So please memorize the condition for this reaction with its specific temperature. And what will happen in this case, you are going to use the substitution where I got my hydrogen attached to the benzene will be replaced with NO2 group. So NO2 group here, where does it come from? Where does it comes from? Actually, it comes from this one, HNO3. If I break down the ions in this one, you got OH minus and NO2 plus. So NO2 comes from here. So your byproduct in this case will be plus water. Please remember that this is a bit different from before. It's not hydrogen halide. It will be H2O as your byproduct. For information, this nitration reaction can be conducted in the experiment where you can observe the yellow oil produced. So this yellow oil is referring to this product. Let's go to the next reaction, the fourth one. I got acylation, or the name will be Friedel-Crafts acylation. And in this case, I got my benzene reacts with the reagent. This is the structure of it with Lewis acid. So acylation is the substitution of an acyl group into an organic compound. In this case, acyl group will be attached to the benzene ring. So you have to detach the bond between this one. So you can use the Lewis acid and put it at the top of the arrow. So right now your hydrogen will be replaced with acyl group here. So you will get the final product, and please make sure you got the side product, the leftover halogen attached to the hydrogen from the benzene. So this reaction is what we call as Friedel-Crafts acylation. Now we go to the last reaction, which what we call as oxidation. So how oxidation will happen for benzene? I hope you can focus for this part where the reagent for this reaction will be acidified KMnO4, H+. This is a very strong oxidizing agent. When you do the oxidation, you need oxidizing agent. So we can use oxidizing agent, the strong one, which is acidified KMnO4. So you can put H+ for acidic. And right now, the condition for this one will be hot. It will be below the arrow. So how you want to write down the reaction? Only selected of benzene can undergo this reaction, where benzene must be attached to alkyl group. And this alkyl group, you react with KMnO4 in acidic, with condition heat, you can use the triangle. And then what will happen, you will form the product, which is benzoic acid plus water. So how benzoic acid can be formed? The carboxyl group will replace alkyl group here. So there is a selection of alkyl group that can undergo oxidation of benzene. I'm going to focus different alkyl group here. So let's go to the first structure, A, with benzene attached to methyl. So for methyl, you got carbon with 3 hydrogen atoms attached to it. So these hydrogen atoms are what we call as 3 benzylic hydrogen atoms. So the reaction can be progressed where the substitution of methyl with carboxyl group. So you can form benzoic acid. However, if I got different structure, B, so B, you got benzene attached to isopropyl group. So this isopropyl, we will focus for this carbon that attached directly to the ring. So this carbon, I'm going to give the numbering 1. So this carbon number 1, you got 2 methyl group and 1 hydrogen. So if you take a look carefully, in order for alkyl groups that attach to the benzene to undergo oxidation, that alkyl group must has benzylic hydrogen atom. So in this case, structure B, you still got one more left, so the reaction can progress from isopropyl benzene to form benzoic acid. Now let's go to the next structure, C, where benzene attached to carbon with 3 methyl groups attached to it. So in this case, this carbon that I'm going to focus about, this one, got no benzylic hydrogen atoms. So the oxidation cannot proceed for this case. So I hope all of you can understand special case for oxidation for different type of alkyl groups that attach to the benzene. Not all of them can undergo oxidation. In order to do the oxidation, you have to make sure your benzene that has the alkyl group, the carbon that directly attached to the benzene ring must has the benzylic hydrogen atoms. So that's all 5 reactions of benzene. I hope all of you are clear with the reaction of benzene in this video. Thanks for watching. I'll see you in the next one. Bye.